Hey everyone, welcome back. This is lesson 11, radicals, and today we're going to be applying radicals to the concept of perimeter. So we're going to start with this model problem. If you're not sure what perimeter is or you need a quick reminder, there is a link on the main page for the vocab word perimeter, and that's what we're going to be talking about today. So model problem, find the perimeter of the given rectangle with the dimensions labeled. So I'm going to find the perimeter of this rectangle. And obviously, as you can notice, they're going to involve radicals. So I'm going to start by writing a really long addition problem. The perimeter means the distance around a figure, and in this case, I'm going to add all four sides up. Since this side is 4 radical 2, this side will also be 4 plus radical 3. This side will be 4 plus radical 3. Since this side is 2 minus radical 3, this side is 2 minus radical 3. Sometimes it's a good idea to add to show all the different dimensions in a picture. Now what I'm going to do, I'm just going to change colors so that we don't get confused with the two colors that I'm using with this work and what I want to show over here, is I'm going to write a really long addition problem showing that I'm adding all 4 sides of this rectangle. Here's my top. I'm going to add on the right side, I'm going to add on the bottom, and I'm going to add on the left side. So I have all 4 sides of my rectangle. And now I'm going to apply what we used yesterday, which is adding or subtracting radicals. Before I do that, I might even look at just the things I know I can add or subtract. I'm going to change colors real quick. I'm going to use a highlighter here. So I see these constants all by themselves. There's a 4, there's 2, there's another 4, there's another 2. I know, and before we even learned radicals, that I can add all of those together. So I'm going to do that. 4 in my calculator. 4 plus 2 plus 4 plus 2. That would make 12. Okay. And now I also see, I'm going to change my highlighter color. Can I do that? Yes, I can. Okay. I also see, and it's a good idea to circle, I have square root of 3, I have a negative square root of 3, I have square root of 3, and I have a negative square root of 3. It might also be a good idea, just for this problem, to add in my coefficients, which are just 1. Right? There's a 1 in the front of this. There's a 1 in the front of this. A 1 here, and there's a 1 here. Now, if you recall from yesterday, right, when I have the same radicals, right, we call them like terms, like radicals, all I'm going to do is add or subtract the coefficients. So I'm going to do 1 minus 1 plus 1 minus 1. If I do that in my calculator, 1 minus 1 is 0, plus 1 is 1, minus 1 is 0, and I end up with 0. So my answer is going to be technically 0 radical 3. I would always write the same radical, right? I'm using the same radicals in my answer. But this thing becomes 0 because 0 times anything is 0. So 0 radical 3 is just going to be 0. So my final answer is just going to be 12. How nice is that? And we will talk about so that happened to work out very nicely. But most of the time, you will have a radical in your answer. And we will talk about different strategies using between the differences between what you would do on a multiple choice problem versus the chance and the strategies that you would use when we're doing like a part 2 or a show work problem. So we have 2 more problems to work on right now. So pause the video, make sure you have all this copied, and we'll move on. Okay, so another problem. Find the perimeter. Again, we're talking about that word perimeter. Again, if you don't know what it is, go check out on the main page on our word wall. The perimeter of a rectangle in simplest radical form, there's that phrase again, in which the length is radical 98 and the width is 5 radical 2. Again, these words length and width relate to dimensions, of a rectangle. How long is it? How wide is it? So I really like anytime they name a shape and they're giving me like numbers that go with that shape, I'm going to actually draw the shape and I'm going to label it. Ooh, terrible rectangle, sorry. The length is radical 98 and the width is 5 radical 2. And there you go. If you switch the labels, that's okay also. And now I want, again, the perimeter of that, which means I'm going to go around all 4 sides. So I might want to label the opposite sides. Okay, switching pen colors just so I don't confuse our work. Let's use blue. I'm going to now write a very long addition problem showing that I'm adding all 4 sides of this shape. Okay. Right now, it looks like I have some things I can add together. I can add together like radicals. So for example, I have a radical 2 here and I have a radical 2 here. So I can add the coefficients of those guys together. So I'm going to add 5 radical 2 plus 5 radical 2. Remember, we just add the coefficients in the front. So 5 plus 5 makes 10. So my final answer when I add those guys together is 10 radical 2. Okay, I'm going to do the same idea and use the same idea, except I'm going to now add radical 98 and radical 98 together. Notice right now there's no number in the coefficient spot, so I'm just going to add a little 1 in here and a little 1 in here. And that adding is going to be really easy. 1 plus 1 makes 2 radical 98. And because right now I can't add these two together, I'm just going to keep a plus sign in between them. Remember, I can only add like radicals. But, so at this point I kind of stop and like, this is all I can do right now. I can't add these together right now. But this hint that they gave me, simplest radical form, makes me think that one of these radicals could probably be broken down and be more simplified. So that's what I'm going to do. Again, we're getting back to simplifying radicals. If you are not confident on how to use your calculator to simplify radicals, please watch my video on simplifying radicals using your calculator. So I'm going to do the first step in that, which is to list the perfect squares. 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10. Yeah. Okay. And then I'm looking at my calculator at y equals 98 divided by x. And I'm looking at my table for any numbers that are on this list, and I happen to see this one. So I start by rewriting. The 2 is going to stay. 98 is going to turn into 2 radicals, one being my perfect square, the other one being my non-perfect square, because 49 times 2 on my table makes 98. Again, I put the perfect square in the front because now I can put this whole front piece in my calculator, 2 times the square root of 49, and I get 14. I'm going to rewrite the radical 2 right now, and now I'm going to rewrite the rest of this problem, plus 10 radical 2. Hey! You notice now they have like radicals. So now I can add them even more. I'm going to add, again, when I have like radicals, all I'm going to add is the coefficients in front. 14 plus 10 makes 24, and I'm going to keep the radical 2. That is my final answer. Now, 2 things right now I can do. I always like to check my work if I can. What I'm going to do is I'm actually going to write this whole thing, my original problem, in my calculator. Now, this is not good if I need a simplified answer, but it is good if I want to check my simplified answer. So I'm taking a second right now and I'm typing in the square root of 98 plus 5 times the square root of 2 plus 98, radical 98 plus 5 times the square root of 2. and I get a big decimal, and that decimal I'm just going to jot it down over here, 33.9411255. Let's see, right, that's what this equals. Let's see if our answer equals that as well. Because if it does, then I know I did it right. Aha, it does, so I'm good. Again, for a multiple choice question, I probably would write this down and probably go right to my calculator and type this in and then see which answer matches that decimal. But because I can't do that, there aren't multiple choices, I had to go through the whole process, adding the like terms together and then simplifying. You could have also simplified right at the beginning, just taken radical 98 off to the side and simplified it, and then I would have written a much different first edition problem, and then everything would have been like radicals. Feel free to pause the video at this point. Make sure you have all of the notes copied down, and I look forward to seeing you in class.